The acceleration of an object is defined as the rate of change of the velocity of this object. So let's say at initial time ti, the velocity of the object is vi at this moment, and later on at the final time t final here, we measure the velocity of the object to be v final. Then we define as the ratio, the rate of change as this ratio here. So v final minus v initial. So that's the change of the velocity divided by the change of the time, t final minus ti. And we define this ratio as the acceleration. Okay. And let's also use this delta t here to represent t final minus t initial, that's time interval. And the change of the velocity, we call it delta v. Now, because we're interested in the instantaneous acceleration, so let's take a limit of this ratio here. Let's say we have the limit of the final time approach initial time, and also the limit of delta t approaches 0. Then what we have here is called instantaneous acceleration, and that's the definition of the derivative. So we get dv dt. Okay, so that's the instantaneous acceleration from the derivative of the velocity. So reflected in the picture here, so let's say we have vi vector here and v final vector there. And if we do v final minus vi, we get this delta v by pointing from vi's head toward v final's head. So that's delta v here. And the direction of delta v is going to be the same as this acceleration's direction. Okay, so here is kind of average if you talk about the delta v. So when we take delta t approaches 0, then this average acceleration's direction approaches instantaneous acceleration's direction in that limit. Okay, so let's talk about how to take this derivative if we know the expression for this velocity v. So let's say v equals 3 components, right? The x component, y component, and z component. Right? So iz, k hat here, they are unit vectors. Okay, so if I take the derivative, I get a. And this derivative need to be done independently for these 3 components. So for the x component, I have dvx dt, so that's the I hat component, and dvy dt is j hat component, and dvz dt, that's the k hat component. Okay, so that's also ax component, ay component, and az component. And remember that the velocity here is the derivative of the position vector, right, dr dt. So the acceleration here is actually the second derivative of this position vector, right, with respect to time.